Well, question number 3, let us start with this. So, okay. So the graph shows the position of an object varies with time interval from 0 to 3 seconds. With which point does the instantaneous speed of the object equals its average speed over the interval? Okay. Now, what is instantaneous speed? What is average speed? Instantaneous speed is nothing but displacement at a given time divided by time taken. For example, let us take for at this point A. At point A, what is the displacement of the particle? 1 second, 1 meter. And what's the time? Time taken is 0. 1 by 0 is equal to infinity. Okay. But if I take the, what you call the average speed, the total displacement of the particle is 1 and time taken is also 0. So, but it is not defined over here. Okay. So, 1 by 0 which is also infinity, but the infinity is not defined, so we cannot consider the point A. Let us consider point B here. At point B, if I consider, so this will be my instantaneous position, which is equal to 1.2 meters nearly, divided by time taken. Time taken is nothing but 1 second. 1 second. So which is equal to 1.2 meters. 1.2 meters is your instantaneous speed. And what is the average speed? Average speed here should be obtained by taking a tangent here. Let us take a tangent here. Let us draw the tangent like this. If I draw the tangent here, and let me take up, for example, let me take up, this goes like this over here. It starts here, and let me take up this point here, and this point over here, this point over here, this point over here, right? So this point could be something like around 1.5 seconds, I think, right? Maybe 1.5 meters, 1.5 meters here, and this point could be 0.8 meters, 0.8 meters, and as a result of it, time taken is 2 seconds over here. So the slope here is nothing but 1.5 minus 0.8 divided by 2, which should be equal to how much? 0.7 by 2, which is equal to 0.35 meter per second. What is this now? This is your V average. What is the V instantaneous I got? V instantaneous 1.2 meter. So definitely B is also not the right answer, right? Now let us take up C over here. At C, if you see, this value is around 1.8 here, right? This value is 1.8 over here. So 1.8 meters is the displacement divided by time taken. What is the time corresponding to it? 2 seconds. 2 seconds. So this is equal to 0.9 meter per second. What is this now? Instantaneous velocity. We have got this. Now what is instantaneous average velocity here? Average velocity here is nothing but you draw a curve. Okay. It is more clumsier over here. Let me draw a tangent here. Let me draw a tangent here. It goes like this. It goes like this over here. It goes like this over here. So let me consider this point and this point over here, right? Between this point and this point. If I do this, now this value is 1.8 minus 1.2. I have considered already. 1.8 minus 1.2. And what is the corresponding time? Corresponding time could be around 2 and around 1.1 here. 2 and 1 here. 1 here. Which should be around 0.6. Right? So what is this now? 0.6 meters per second is your average velocity, and here it is 0.9 meter per second. So these two are seen to be much closer with each other. Okay, if I do the exact graph, I will get it correctly. Okay, but since there are approximations I have made, I am getting this closer to each other, and as a result of it, the answer here is C. Okay, this is answer C. So if you do not understand this problem, just drop in your comments. Maybe I can take up a fresh page and then do the same thing once again for you. Okay, now let us move on to question number 4.